Alright, students, this is going to be a video on the practice set for Saxon Math Course 3, Lesson 91. Now, Part A of our practice set says if you know the scale factor between two polygons, how can you find the ratio of their perimeters and areas? Now, remember that the ratio of perimeter will always be equal to the scale factor itself. Whereas the ratio of the area, because we're using units squared, is going to be the scale factor squared. Alright, now remember this should be in your notes from the lecture itself. We had that table at the beginning of the lecture. If you know the scale factor between two polygons, remember a polygon, any flat shape, circles, squares, any polygon, their perimeter, the area, scale factor for the perimeter, and scale factor squared for the area. Now, practice set B. A wallet-sized photo is 1/2 of the dimensions of a 5" by 7" photo. What fraction of the 5 by 7 photo is a wallet-sized photo? Now, our scale factor here, our dimensions are 1/2, so our scale factor is 1/2. To find the scale factor for the area, remember that it's the ratio of the area is the scale factor squared. So we're going to put 1/2 squared, and 1/2 squared is 1/2 times 1/2. Half of a half is 1/4. If the area is 1/4 of the size, then the wallet-sized photo is 1/4 of the 5 by 7 photo. That is practice set B. Now practice set C says a triangle with vertices at 0, 0, 1, 0, and 0, 2 is dilated by a scale factor of 4. The area of the dilated image is how many times the area of the original triangle? Now with a question like this, your first instinct might be to pull out your graph paper and graph these points, and then do the dilation itself. But remember, you're given the scale factor and asked for the ratio of the areas. So we write down that our scale factor was 4. And area, the ratio of area, is the scale factor squared. So we have 4 squared. Now 4 times 4 is 16, which means that it will be 16 times as large. That is practice set C. Remember, if you can solve without graphing, sometimes it is easier to solve without drawing the graph itself. When you are given the scale factor, you can find the ratio of the perimeters and areas even without drawing the shape or seeing a picture of the shape. Now for practice set part D, we are told to find the scale factor of the small rectangle to the large rectangle, find the ratio of the perimeter, large to small, and the ratio of the area, large to small. Now here we're giving two rectangles. One is a 2 by 4 rectangle, the other is a 6 by something rectangle. We're not quite sure. Now we can see that the 2 becomes a 6, so our scale factor, we're going to have it go from the larger to the smaller. So we're going to have the large, which is 6, over the small, which is 2. And 6 over 2 is the same as 6 divided by 2. Now 6 divided by 2 is 3, so our scale factor here is 3. Remember that the ratio of the perimeter is equal to the scale factor. So here it's 3 over 1, or 3 to 1. Now the ratio of the area is going to be 3 over 1 squared, or 9 over 1. Which could be rewritten as a ratio using the colon as 9 to 1. Notice we're still having the perimeter be equal to the scale factor. We're still having the area be equal to the scale factor squared. 3 times 3 is 9. 1 times 1 is 1. Now, practice set E says, what is the surface area and volume of a 1" and 10" cube? Find the ratio of the surface area between the two cubes and of the volume between the two cubes. Now, let's start off. I made a little chart to help us keep track of our data, but we're going to be doing the math over here. Now, starting with surface area. The formula for surface area for a cube, because every side on a cube is equal, and there are 6 of them, would be the area of one side, length times width, times 6. So for our 1-inch cube, our length and our width are both 1 inch. For our 10-inch cube, the length and the width are both 10 inches. Now, 6 times 1 times 1 is going to be 6 square inches. 6 times 10 times 10 is 6 times 100, or 600 square inches. So let's put that in there. Surface area, we got 6 inches and 600 inches squared. Now, for the volume. Volume is going to be length times width times height. So we're going to have 1 inch times 1 inch times 1 inch. 1 times 1 times 1 is 1 cubic inch. On the other hand, we're going to have 10 times 10 times 10, which will be 1,000 cubic inches. Now, when we put these into our table, we're going to have 1 inch cubed and 1,000 inch cubed. Now, that found us the surface area and volume of the two cubes, the 1-inch cube and the 10-inch cubes. We're then asked to find the ratio of the surface area between the two cubes and of the volume between the two cubes. Now, the ratio between the surface area is going to be 6 over 600, which is 1/100th. The ratio for volume is going to be 1 over 1,000. Now, let's talk about why this makes sense. Our dimensions are going up by a factor of 10, a scale factor of 10. So it would be 1 over 10. Now, if we looked at surface area, it ends in area. So it's going to be 1 to 10, but squared. So 1 times 1 is 1, and 10 times 10 is 100. So it fits with the pattern that we saw in the lesson today. Volume would be 1 times 1 times 1 over 10 times 10 times 10, which is what we saw down here, our scale factor to the power of 3, giving us 1/1000th. Now, for part F, we are showed that a square has sides 10 centimeters long. A second square has sides 50% longer. Now, with that, 50% of 10 centimeters is half of 10, and 10 again. Half of 10 is 5. So we would have 10 plus 5, which is 15 centimeters. Because remember, 50% is a half, or 0.5. Now, the scale factor. What would I need to multiply 10 by to get 15? Well, to find that, we can divide 15 by 10. 15 divided by 10 is going to be 1.5. Now, the ratio of the areas. Now, the ratio of the areas is the scale factor squared. We just found the scale factor in the previous part. The scale factor is 1.5. Now, 1.5 squared is going to be similar to 15 squared, because 1.5 looks like a tenth of 15. Remember, though, that we're going to have to carry the decimal. So if we have 1.5 times 1.5, if we remember that 15 squared is 225, we can know our answer to 1.5 times 1.5, but we have to remember there's 1 digit after the decimal, 2 digits after the decimal, so we need to have 2 digits after our decimal in our answer. So our answer is going to be 2.25. Alright, I'm going to leave this on the screen for just one moment longer, and then we're going to move on to the next example. Alright, so, Part G. Part G talks about a pizza shop which is offering a double your pizza deal, where they're saying that for the price of a 10-inch diameter pizza, you can get a pizza that has twice as much pizza in it. Now, you might think at first that that would be a 20-inch diameter pizza, but that's not quite right, because remember that when we're making our scale factor apply to our area, we'd have to square it. So it'd really be a number which is closer to the square root of 2 times 10. Now, as we're looking at this though, it's a multiple choice question, so we can always guess and check, or fill out all the work for all of the answers. A 10-inch diameter pizza would have an area of 5 times 5 times pi, or radius times radius. Remember, radius is half of diameter, so a 10-inch diameter pizza has a radius of 5. 5 times 5 is 25, so it would be 25 pi. And as our area, it would be in inches squared. Now here, a 12-inch would have 36 pi inches. 14 would be 49 pi inches squared. 16 would be 64 pi inches squared. And 20 would be 10 times 10, which is 100 times pi square inches. Now, over here, we are asking which one has an area which is twice as big as a 10-inch pizza. Now, 2 times 25 pi is going to be 50 pi. Of these 4 possible answers, only one is close to 50 pi. It's 49 pi. So if we're looking for the one which is doubling our area, the closest one would be a 14-inch pizza. There's one more, and that is H. Now, H talks about a 6-inch diameter balloon holding a pint of water. And it wants to know how much water would a 6-inch radius balloon hold. Now, at first, it might be a little bit difficult to find our scale factor. However, remember that radius is half of the diameter. A 6-inch diameter balloon would have a radius of 3 inches. So moving from 3 inches to 6 inches, from 3 to 6 is times 2. So our scale factor is 2. Now, volume. Remember that volume is measured in cubic units. When we measure our volume in cubic units, our ratio will be our scale factor cubed. Now, 2 to the power of 3 is 2 times 2 times 2, or 8. Which means that we're going to have 1 pint, which is how much a 6-inch diameter balloon would hold, times 8, which would be 8 pints, as our final answer. Those are our practice set. If you have any questions about the practice set, feel free to leave a comment using the private comment function in the Google Classrooms. I will be watching those and waiting for you to message me. If you message me with questions, I will respond to you. Alright, I hope you all have a wonderful day. There will be a video uploaded shortly with the starred problems for the lesson.